Well, hello there again, friends. Today is 7/25/2022, and today is the Odin Project Vlog Day 136. And this is part 2 of the project testing practice with Jest, and I completed it by completing number 4 and number 5. So let's look at those now. And boy, was Caesar Cipher a doozy. I got I'll preface by saying I got about 90 to 95% of it done, and then I just got myself into a corner, basically by creating a for loop, which you need, but inside of the for loop, I made the mistake. Don't do what I did. And I already erased the code, so I was gonna show it to you, but it doesn't really make sense. It wouldn't have made for a good video because it'd been hard for me to explain all the mistakes and the errors. But basically, I put local functions inside of the for loop, not intentionally, mostly unintentionally, and I didn't realize I was doing that until the end. I had a bunch of return statements that, as you know, when you do a return statement inside of a for loop, it exits the for loop. So you can't, so I had to have a return statement because I had to declare my variables, or I had return variables that needed to be spit back out to the for loop. Well, the only way to do that is to return the variable, and you have to return the function. It's the local function itself outside of that function bracket in order for it to pass back up. Well, since you're in a for loop, it exits the loop as soon as it sees that first return statement. So, yeah. So needless to say, my logic was great. I got everything to where I wanted it, but the code just wasn't going to work. It just didn't flow right. The execution of flow was not there. So I rewrote the whole thing and refactored it. So with that said, we'll take a look here. So basically, they go over the Caesar function on this website that I won't go over to. I'll have you guys do that in your own time. And they want you to write a test for it. So one of the things is a couple things here. You don't forget the test wrap from Z to A, or Z to A, vice versa, but definitely from Z to A. Don't forget the test skipping or test keeping the same case. Don't forget to test punctuation. For this one, you may want to split the final function into a few smaller functions, and that's actually where I got myself kind of hung up, is I was focused so much on making the smaller functions, and I wasn't really paying attention to where I was putting them, which is key. So you'll see the code now. I have them tucked away inside of constant variables, but they're sharing that global namespace through that function, or through that constant variable. So they work without having all the return issues because they're not inside a for loop. One concept of testing is that you don't need to explicitly test every function you write, just the public ones. So in this case, you only need to test for the initial Caesar Cipher function. If it works as expected, you can rest assured that your smaller helper functions will do what they're supposed to do. So that you really only need to test for the main function is what they're basically saying. So with that said, we'll hit the editor here. And I can't blow this up, so I'm sorry if this is small to see. I try blowing it up, and with having the terminal open and everything just gets insane too quick, and it's hard to understand the screen. So hopefully you can understand. Hopefully you can see this. If you're watching on a computer or something, you're fine. If you're on a phone or tablet, you might have a hard time, but never the case. Let's just get started here. So I have a function Caesar Cipher here that takes in string, and so that's going to take in our test. Here's my test for this one. We're going to do a Caesar Cipher off of practice with a zebra exclamation point. So we're testing for caps, a punctuation, and a rollover from Z to A. For this cipher, we're going to be shifting 1. A shift of 1, meaning we're going to shift every letter to the next available letter in the alphabet to the right by 1. So we got constant letters equals A through Z, and a string, and a constant cipher is basically B through A with the shift. And that's how we're going to solve the shifting concern from Z to A. So constant is lowercase letter. So I defined a is lowercase as a true-false statement. So if letter equals letter dot lowercase, so for those are the same, and letter is not equal to uppercase, we're going to return true. Otherwise, we're going to return false. Sorry, Tourette's is active. And then we have another constant variable called is uppercase, and it's going to take in that letter parameter as well, which these are each individual letter of the string. And then if letter equals letter to uppercase and letter does not equal letter to lowercase, we're going to return true, otherwise return false. So basically we're returning trues if we're lower or upper, and false if we're not. And then I have a constant variable called lower cipher, and this takes in letter again. Excuse me. Takes constant variable index equals letters dot index of letter. And so what index of does, returns the position of the first occurrence of a substring. So basically it goes through letters, and it's looking for whatever letter we're evaluating at the time. For example, the capital Z, we're going to be looking in letters, and we're going to be finding Z. And we find that, we're going to store the index value of that. In this case, it will be 25, since there's 25 here. And we'll store that in index as a number. And then we're going to let cipher character equals cipher index. So now we're going to look at the cipher constant string here, and we're going to locate that index. So say it was the last position, what did I say, 25 I believe it is. It might be 24 actually, with 0 in front, since we're starting index 0. But anyways, the last position, and we're going to see that it's A. And so we're going to let A equal the cipher character. And so that will be our ciphered character, and we're going to return that out when that lower cipher is called. Have an if statement here. If type of string does not equal string, we're going to return not a string. So that's just checking to make sure that our user input is a string and not numbers or something else. And then here we're going to kind of start the cipher itself. So we're going to let cipher output equals an empty string, because that's where we're going to store our output. But we're going to eventually return back to the Jest test. For loop here is let I equals 0. I is less than string dot length I incremental. So we're going to have for loops looping through the entire string that the user entered. We're going to challenge them with an if statement. So the if is uppercase, so this is going to evaluate each individual letter. So if it's uppercase, or double pipes is or it's lowercase, we're going to continue on. So this basically, you're probably wondering why that's in there, and that's basically just to cover upper and lowers. So if there's a special character, if like we have in our example of exclamation point, it will skip this if statement and go down here and into the else, and it'll just be cipher output equals the string that it's currently evaluating. So that will get appended to the cipher output, as you can see with the plus equals. So jumped ahead there, but that's the case if you have something that's not a upper or lower case. So if it is an upper or lower, then we challenge again, is it a lower case, and then the cipher output equals the cipher output is appended from lowercase lower cipher string I. So we go up here, lower cipher, run that, and we have string coming out, letter of index. Yeah, so we run through our lower cipher that I already went through, and then we're returning the cipher character. And then that's going to be, that cipher character is going to be inputted to our cipher output, and you see that plus equals there. So we're going to incrementally change the cipher output as we move along, so we don't lose what we already went through. Else if it's a uppercase string, we're going to do a cipher output is equal to plus sign, so we're going to append the lower cipher, and basically this is the same thing as this one, but we're changing the lowercase to uppercase since this is an uppercase true statement. So then we're going to do the same parameters as lower cipher, but then we're going to at the end change it to uppercase and then shove it over to cipher output. So that takes care of the uppercase, and then we're going to return cipher output. And that's that. I won't run it right now because I've got my scroll bar up here to receive, to show you this error here that I received in the second analyze array number 5. So I'm going to wait to run this till the end. Let's see here. Just a second, need a drink. All right. Thank you for waiting. All right, so that will be the explanation for that. So if I went a little fast on that, so if you need to rewatch that for further understanding, I now run the test at the end here so you can see it all working, but it does work. The only thing I will say about Caesar Cipher here is it doesn't account for. See, originally I had a shift in here. I was allowing, like, for instance, I had this and then comma like 1 like that. Allowed the user to input a shift of their own, or 2 or -1. But I'll tell you what, that was one of the things I didn't mention in the beginning. I probably should have. Is that really caused me a lot of problems. There was too many permutations, too many variables at play. It just didn't make any sense to do that. And I just couldn't get it to work. I think if I would have kept beating the keyboard, I eventually would have got it. But, I mean, look at how many permutations you could have if you're shifting, say, 5 or 6 or 7. You would have to have a lot more elaborate code. You can comment below. Let me know in the comments section if you guys decided to take on the shift and didn't make the assumption that we're only shifting 1. And if you incorporated a variable shift, that would be really interesting to see. But if not, no big deal. It doesn't say that necessarily in the requirements. It just says to, do the shift. Although if you read the website, it does talk about what I was just saying, how you can do different shifts so you get different ciphers. But it doesn't say to do that here in the text. So number 5 here, this one's a lot easier than cipher. This is an analyze array function that takes an array of numbers and returns an object with the following properties: average, min, max, and length. And they even give you kind of what they're expecting you to work with. So with that said, when you write your test, remember, write your test first. When you write your test, this is what I wanted to show you. You get a serializes to the same string error when you first run it. And that I had to Google that. So basically, that means that I don't know exactly what it means, but basically, the Jest engine does not like that. Let's see if I can get a good explanation. I think it has definitely something to do with the 2B. It says that it's not strict enough. So basically, if your expected output is the same as what you're getting to the character, 2B will throw you serializes to the same string, because 2B expects it to be that thing, but it does not like when it's the same exact thing string wise. So I don't know if that made any sense at all. But if you use, through my Googling, if you use too strict equal, then it works fine. Or in the Stack Overflow, I'm looking at my other screen right now, it says if you use too equal, it also works. I didn't try that, so caveat on that part. But too strict equal does work. So that's that. So going through the function, we have analyze array. With the input array is going to be what I'm calling the input from the user. We've got a constant average, minimum, maximum, and len for length. Average is so this is input array dot reduce. So if you remember, reduce takes the, I'm trying to make sure I explain this right. So reduce takes A and B, and then A is going to be your previous value. Well, when you run through reduce, it loops through every item in your array one by one. So the first time it goes through, your previous value A is going to be 0 or null, basically, because it hasn't went through anything yet. And then B is going to be your current value, your current evaluated item, which in this particular test will be 1. So what it'll do is it'll evaluate then, and then run the arrow function, and it'll do A plus B. Well, A is nothing right now, so just consider it 0. And then we're going to add B to it, and so B will become 1. And then reduces, like I said, is a callback function inherently, so it's going to call back and run reduce again against the next number in the array, number 8, or the number 8, and then A will become 1, because that was our permutation, our mathematical solution from the previous callback, and then plus B of 8, so that would be 9, and then it would loop back through, and if that makes sense. And it's going to go through all of them until it gets till reduce completes and there's no more items in the array, and then it's going to do a division by input array dot length, which is how you get your average, and that's going to spit that answer into AVG. Down here, made this simple. There's other ways to do this too, guys. Again, like I always say, my way is not the best way, it's just a way, and it's not the only way. Have constant minimum, maximum length len. So for const min and max, minimum and maximum, I used math.min. And so a long time ago, we talked in a video, actually, ironically, it was over Jest testing, I believe, the first time we did it. We talked about using the triple dots for multiple arguments. So we want to use that here because we don't know how many numbers the user is going to put in, so we want to use triple dots for input array, and then math.min will give the minimum of that. And same thing for .max. Our input array will be all the items it's going to search for, and it's going to locate the max, return right there, returns the largest of the set of supplied numeric expressions, and min will get set as minimum, maximum will get set as maximum. Had a typo there. Did I? Yeah. Had a lot of typos. Wow. Oops. Goodness gracious. Alright. There we go. Save that. Okay. And then I have length equals, and this is just simply input array.length. So we're going to, that'll always give you the length of the array, and then we're going to put that value to len. And then down here, const, since the instructions were they wanted an object back, we're going to give them an object. So we're going to create a variable called const output object, and that's going to receive average, min, max, and length for the properties, and the keys are variables of average, min, maximum, length that we just got from up here. And so we'll input those as an object and return the object. And I added didn't say this in the last one, but obviously it goes without saying, we do our exports here for Caesar Cipher and analyze array. And so that is that. And so I went over the strict equal on the test. So you only had to do one test. This is the test that they tell you to do in the sample or in the text. But I went ahead and ran 3 more just for fun. I wanted to prove and show that this was robust and works with duplicate numbers, the same value and smaller, and then also will work with a single digit, and also will work with negative numbers and a mix with positive numbers as well. And so if you run all the tests, as long as I didn't typo anything here, everything should be good. Yep, 11 passes. So here's my my cipher, my Caesar cipher, and then here is my 1, 2, 3. Here's my four tests, Jest tests for the analyze array. So that is it for that. Oh, see if I missed anything. I feel like I'm missing something. I don't think so. This ends that. So I will be publishing this to uploading my GitHub, as you guys should too. After you're done here, and then publish it to the project's solutions down here. So make sure you do that. And that is it. Why do I feel like I'm forgetting to explain something? It's one of those days. It's been a really, really long day. So I just came off on call, and it was a brutal week. So I wasn't going to make a video today, and I was like thinking at the end of the day, I'm like, better, because tomorrow's going to be really busy at work, and may not have any energy afterwards to make this video, whereas now I have a little more energy today. so that's it. So with all that said, thank you for coming along the ride with me today. I hope you learned something and had a little bit of fun too. Please like, share, and subscribe for more content, and let me know in the comments section how you guys ended up on these Jest tests. So with all that said, till next time, see ya.